looking at lesson 10.4, and we're going to look at parallels in space. So we'll be looking at parallel lines and parallel planes. We're going to define parallel figures in space, and then we're going to look at a whole bunch of different theorems about parallel figures in space. So first we'll define parallel planes. Parallel planes are two planes that do not intersect. And a line parallel to a plane is a line that does not intersect the plane. So planes can be parallel to each other, and lines can be parallel to planes. So our first theorem that we're going to look at says that two lines perpendicular to the same plane are parallel. So in this example, we have this yellow line and we have this green line. Both of them are perpendicular to plane M. And that means, according to this theorem, that the yellow line and the green line are parallel to each other. All right, our next theorem says that if two lines are parallel, then any plane containing exactly one of the two lines is parallel to the other line. So here's two lines. We have line CD and line AB. And so here's a plane N, that contains line AB. And since line AB was parallel to line CD and line AB is in plane N, we can say that plane N is therefore parallel to line CD. And then we have plane M that contains line CD and line AB. Our next theorem says that a plane perpendicular, which means that it's intersecting at a 90-degree angle to one of the two parallel lines, is perpendicular to the other line also. So here is a picture of a plane N, and plane N is perpendicular to this yellow line. And since this yellow line is parallel to this green line, that means that plane N is also perpendicular to that green line. All right, our next theorem says that two lines parallel to the same line are parallel. So if you have two lines and they're parallel to the same line, then those two lines are parallel. Our next theorem says that a plane intersects two parallel planes in parallel lines. So here's a picture. Here's plane M and plane N. Notice that they're parallel. And then you're going to have a third plane, this green plane, that's intersecting these two parallel planes. And when it intersects these two parallel planes, it's going to create two parallel lines. Next theorem says that two planes perpendicular, which means they intersect at a 90-degree angle to the same line, are parallel. So here's a line. Here's line N, which is perpendicular to that yellow line. And here's plane M, which is also perpendicular to that yellow line. So there's two planes, both perpendicular to the same line, which means that plane M and plane N are parallel planes. All right, our next theorem says that a line perpendicular, which means it's going at a 90-degree angle to one of two parallel planes, is perpendicular to the other plane as well. So here's a picture. We have two parallel planes, M and N. Our green line is perpendicular to plane M. And since plane M is parallel to plane N, that means that this green line is also perpendicular to plane N. Our next theorem says that two parallel planes are everywhere equidistant. Equidistance means that it's the same measurement all across the two parallel planes. So here's two planes. So any distance between plane N and M is going to be the same measurement. All right, so here is a question. If you have two lines, so L and M, and they're perpendicular to the same line, but they're not parallel to each other. So they're perpendicular to the same line, but they're not parallel to each other. What is their relationship? All right, the answer would be skew, right? They would not be in the same planes. So here's an example of that. So notice how line L is perpendicular to the orange line and how line M is perpendicular to the orange line. But notice how line L and line M are neither parallel or perpendicular, or they're not even in the same plane, which means that they are skew. Line L and line M are skew lines. All right, here's a yes or no question. Given a line L and two planes P and Q, suppose that line L is parallel to line P. And if line L is perpendicular to plane Q, is plane P perpendicular to plane Q? So the answer to that would be yes. And so we're going to take a look at the picture to show why that answer is yes. So here you have line L, which is parallel to plane P. And we said that line L was perpendicular to plane Q, which means that plane P and plane Q are also perpendicular. All right, next question. Given a line L and two planes P and Q, suppose that line L is parallel to plane P. And if plane P is perpendicular to plane Q, is line L perpendicular to plane Q? So the answer to that one is no. So see how this one was different from the other question, because on the other question, you started with if the line was parallel to a plane, then those two planes are perpendicular. This one's saying the two planes are perpendicular, so does that mean the line is perpendicular? And the answer is no to that one, and we can look at it here. So here's the picture of a case where it was yes, right? However, but look at this, okay? Notice how line L is on plane Q. And here's another example of why that answer would be no. All right, go ahead and try some problems on your own if you would like. And thank you for watching.